Hello, this is another series of courses that I wanted to do for a long time. And this series is actually about research in what we call AI for science. So firstly, I'd like to make a disclaimer that AI for science is not easy and it's a huge topic. Now, the end goal of this course is to familiarize the audience to be able to carry out things regarding to uh, the physics and medical uses. Uh, Mostly, we will be, or I should say, exclusively, I will be focusing on, um, let's say, drug synthesis, all these kind of things. We're not going to focusing on MRA image, which is not a, let's say, which has been quite old, and there are a lot of courses about that. Now, there are a lot of things going on here. So, what this course isn't is a fast pass for you to publish a paper. If you have been joining any community, then you will know that there is a huge thing about, let's say, I got an idea from my teammates, from my professors, from my mentors, and then I just shared it online. So don't believe it when people say, okay, I'm going to share with you so that you can publish on the top journals or conferences. No, that is never going to happen. However, I do find two things. First of all, let's say just medication, AI facilitated medication design is actually one of the most useful and beneficial aspect of AI. To give you some example, let's say if you want to develop something, you have to go through years of trials. And many of these trials have to be done physically. What does this mean? It means that, let's say I'm going to simplify this a lot so that if you don't have the chemistry or biology or physics knowledge, that's okay. All right, that's okay. But I'm going to simplify this a lot. Let's say we have an ingredient, something, some magic pill that I want to test. Now you have to really carry out an experiment. And because there are thousands and thousands of options to design these, it's going to cost you a lot of money. So it's not very weird or unseen where 10 years has been going into developing like some kind of medicine. And this medicine is not like revolutionizing, but this is the agony that pharmaceutical researchers have to endure. And this has been largely kind of ignored, except for those who are working on this field. Now, why this is important? So there are a lot of things that seems very cool but are not real. Let's say, for example, there is a very old approach that we all use and that determines our life more or less, and that is the credit rating system in the bank. It exists long before any AI has taken place. Now, I worked in one of the largest bank in China, the second largest to be exact. So it's very, very normal that a decimal change will bring about, let's say, 600 billion yuan changes. And that is actually the big minimum amount that the project that I'm doing. Like, that's how important that is to do this. Now imagine another application. Okay, imagine another application. Let's say we are investing a lot of things. into, say, generating a voice that is similar to someone you want, like, say, Donald Trump. Well, first of all, this is interesting. But on the other hand, in the long run, I don't think it's benefit as much as, for example, the banking system. This is going to be fun. I agree that, and fun is important. But if, say, we are using the AI mindset, how are we going to even evaluate how close you are to actually Donald Trump saying it? So, also, there are things that are more or less doomed from the start. For example, ChatGPT is very useful, but more or less, I think, as not a chatting robot. Now, it sounds very cool if, let's say, you have a virtual friend, and we have been kind of preaching these ideas for years. Like you have a virtual friend, and you talk with him 24 hours a day, and he can understand everything. But if you do any chatbot, like with normal conversations, how is this going to help you? Most of the chatbot will just tell you jokes. It will fail to grasp, like with multi-round of dialogue, it failed to grasp. But this is something that is possible, but will take hundreds of years to complete. And people are not telling you that because it's much easier to understand. So you can argue everything about that, but I think we can actually say this drug design is actually useful. Secondly, there is actually a surprising lack of documentations and knowledge on this, partly because we call it interdisciplinary subject. So you have to learn to code. You have to know AI related things like how to train neural network, how to design neural network. You probably need to know if you're going in a route of geometry, geometric deep learning, something about Riemannian geometry. You probably need to know large language models. You probably need to know a lot about the actuality of how you really understand what this application is about. And even if you understand the application is about, how do you clean the data? Because it is not in a very easy format such as a picture. So all these, I think, are something that I want to cover. However, I'm not going to cover something like, let's say, how do you call it, a new idea for you to publish a paper. And I will try to stay away from mathematics as much as possible because more or less, I'm also doing another series that will cover some of the mathematics and since this area is fastly growing, there's no way that you can carry it out. And this is going to be very different from what I do with mathematics. For mathematics, you absolutely want a very solid foundation. So you should read this book, and then you read this book, and you read the book. It is generally not advisable to say, I have this problem. Can I just search it online and then I solve it? No, that's generally not possible. However, let's say we want to configure something about Ubuntu. You can, of course, spend a year learning how operating system works. You can also spend another year just, let's say, study the Ubuntu kernel and do these. And still, you might not solve the problem because, for example, there is a bug in the CUDA driver. And how do you do that? You search on internet. So this course is taught more or less in a way that is throw you into the oceans to help you to swim. But this, in my opinion, is actually more or less a correct approach because just imagine doing a PhD in medicine and then a PhD in computer science to do any research regarding that. And another thing that I'm not going to do is that I'm not going to focus too much on the tricky part in terms of especially cable computations. Now, if you want to publish papers, now people are more and more aware that if you publish paper in any way, if you do a lot of tuning, what you claim to be the innovation point may be just a trick. And the general consensus is that we have to keep things simple. Yes, we do not have a very well written rule on what exactly is allowed and what exactly is not allowed. But in general, if you do a lot of tricks in your training and you show it in the appendix, people are not going to be happy about it. Okay, the third thing that we're going to do is we're going to actually more or less combine some examples pointing out which source that you can look into. What are the actual options here, such as are you using Colab, are you using like a remote server, which is better, how to experiment, and these kind of thing. Also, how do you, for example, use ChatGPT to help you to write some of the code, but not all of them, and etc. etc. So this is more like a project, a guided project. We would probably replicate something from a paper, but this is not, again, going to be like, okay, we're going to do everything and I'm going to teach you everything about it because, as I say, this is more like guided project. The more important thing in this field is that you can find relevant, especially readily written code and adjust it to your own because you really don't want to write everything from ground up. Okay, so thank you very much, and we will continue with this uh, for a long journey. This will not be updated regularly because obviously it takes time to wait for the results and so on, and you might not be able to reproduce my result due to the configuration. All these things is part of the problem. So thank you very much, and we hope we can have an enjoyable journey.